So we have in today a marine transceiver. That's this thing behind me here. And you use it to communicate between ships and boats. Think of it as like a conventional CB radio or a normal walkie-talkie, but this thing works on long-range FM, so usually 25 miles plus, and it's come in because it's no longer making the audio noises when you're receiving information. Let's just first take a look at how this works and then see if we can fix it. This is the transceiver, so I don't own one, I've not used them, but I'm obviously familiar with walkie-talkies and the general idea of how they work. The customer's provided some basic details as well, and I do love sea fishing and go on boats, so I kind of know something about these. I believe channel 16 is normally the channel for general communication when you're out at sea. Yes, there you go, you can see that's your distress signal, so that's like for general communications. And then you've got a load of others. So what we can see is if we push to talk at the side, you can see it transmits, and let go and we should be in receiving. Now, I could either buy another one of these to actually transmit some information, or make an FM transceiver to send the frequencies to this. But again, the customer's told me, if we just lower the squelch down, this is like, I presume, a sensitivity to receive. So now you can see it's busy, because we should be receiving information. So this should just be static, like when you turn on a normal radio or walkie-talkie and you're just hearing static. And that's the complete teardown done. So we now have access to the motherboard, which we can now inspect and look for any visual issues first. We'll then also try and power it from the bench. So we can see from this battery, we know we've got ground and voltage here, which when connected goes to ground and voltage, with the bench set to 7 volts and hooked up. So considering the customer had been inside and potentially dropped some steel wool, I'm just going to observe all this with a microscope, see if we can see anything obvious, because it does seem like something's just maybe resting on this board somewhere, causing it to be intermittent. And looking all over this board, I can't see anywhere where there's any short or wire left, so something's probably blown with an initial short maybe. And looking under the thermal camera, that's pretty quick and obvious right there, 76 degrees. I doubt that's normal. It might be, because it might be running GPS and be expected, but if we just put the tweezers on that and that, we are looking at this component and this component. So without one to compare to, we've got to use our judgment here as to whether that's normal. And like I say, it might be, but it does seem a little bit excessive in the operating temperature when nothing's really happening. You can see even the CPU is only running at 30 odd degrees. Nothing else at all is getting warm. And checking the other side of the board, we can see again, nothing is getting warm. And that is the heat coming through the board from those components the other side. And that's 45. So it's literally the hottest thing on the board is these two chips. And they just say on 5V0, 3V3, and this one's 1V5. So I'm going to guess they're regulators. And probing on the output confirms that's 5 volts. And probing on the output of this one is 3.3 volts. So that's likely normal. They are getting to 70 degrees, but regulators can run at 70 perfectly fine. And based on the current draw, which is likely the GPS side of this, that's probably just expected. So I don't think we have a fault there either. And you can see, again, this audio's come back and it's just pulsing again. So I don't know whether that is normal and we have an intermittent fault. If we look in this area as well, this looks like where the customer was cleaning. So this is likely where wire has got. And these are the high frequency crystals. So if we actually probe them, this is 120 odd meg roughly. And this one's 250, 260. So the marine broadcast is usually around the 100 and I think it's 150 to 170 roughly megahertz. So these are going to be the important crystals. So what I think I'll do is just reflow all this area in the vicinity in case wire wall has just touched something and made it weak. I'm just getting 360 and about 40% airspeed. We don't want to go too hot and blow components off. These will be high grade, probably COG capacitors and obviously frequency dependent components. These won't be standard components. So we don't want to blow any of these off because they're going to be really hard to replace and even know what they are. And unfortunately, that's made no difference. So I think this one is going to be a no fix. But what I think has happened, and the reason we're not going to diagnose further, is these are very high frequency signals. So even my scope, which I think this one's like 250 meg, you really need like a gig speed scope, which I don't have. Then all these components and high frequency signals are very hard to diagnose efficiently for the cost of the device. The customer has been repairing here, so all the sensitive circuits are all around here. So what might have happened is it might be nothing to do with the steel flakes. It might have simply been the board flex when cleaning and opening this that's damaged. Even just one of all of these components could be damaged, causing this kind of pulsing issue. Now we may have fixed it as well, because this is now a constant pulse, so it's no longer intermittent, it will always pulse constantly. So as one last check, I'll just simply buy a cheaper version of this and try and transmit some signals over to see if it is in fact already working, but my suspicion is that maybe isn't right. And just to confirm, we have a working one here, and if we push to talk, you can see it picks up, but nothing ever comes through. And likewise, if we transmit from this one, you can see the working one picks up, but it only gets static. So it does look like it's the send receive high frequency circuit in here that's bad.